So this is yet another video. We will be discussing the first modification of the basic SR latch, what is known as the level sensitive SR latch. In the previous lecture, I told you that the problem with the basic SR latch is that whenever the inputs S and R they are equivalent to 1, it enters into the indeterminate state, and when we change them back to 0, 0, it actually leads to the oscillation in this circuit. Right? And I also told you that there can be two solutions. One solution to avoid the occurrence of these and the S and R equivalent to 1 at the input. And the other solution is wherein we actually modify the circuit in such a way that even if these inputs occur, they are actually defined. So the first solution is known as a level sensitive SR latch. And the core element is still the same, like I have drawn here is a basic SR latch. It has two inputs S1, R1, and output Q bar and Q. So what I will be doing as a modification is I will be using two AND gates at the input. The first one and the second one here. Then the S and the R inputs I will be feeding S, R, and then there will be a common input to these AND gates, which we'll call C for the time being. So this is S, this is R, this one I will call C. Right? Now you know the behavior of the AND gate. It is enabled only when one of the inputs is 1. So it will be something when C is equivalent to 1, when this enable input C is equivalent to 1, then the external S and R inputs, they will propagate. Yeah, let's reserve inputs for S1 and R1. Just a small change. Let's say signals. S and R signals, they will propagate through the AND gates to the S1 and R1 inputs of the basic SR latch. Right? So in that sense, the latch is enabled. And when C is equivalent to 0, when C is equivalent to 0, so in that case, your signals S and R will not propagate to the S1 and R1 inputs of the basic latch. Simple concept. C is equal to 1, your AND gates will be enabled. S and R signals, they will pass on to S1 and R1 of the basic latch. Storing mechanism is still the same because I'm still keeping my core element is still the same. If I outline it here, this is where my storage happens. What I am changing is the way I am feeding my external inputs to this particular latch. Right? So as a first modification, I'm using two AND gates which have a common input. That common input is C. It kind of acts as an enable. Right? So what we can do in practice is that every time, so we can say that when we are sure that S and R have stable values, by stable values I mean they are not same and equal to 1. So I'm actually excluding the condition S is equal to R is equal to 1. So when you're sure that S and R have stable values, we can enable the latch, or we can put C is equivalent to 1. In other words, we will enable this latch and it will store using the same mechanism. Right? So this is known as a level sensitive SR latch because the latch is only sensitive to the level of this enable signal that for the time being I'm denoting by C. Right? It's also called, sometimes we use a term transparent latch. right? Because these inputs, these signals S and R become transparent to the latch when C is equal to 1. So in that sense, it is sometimes also known as the transparent latch. Now this is how my latch will look like. S and R are my normal inputs. Now I have added an additional input C, which is my control input. And then I have Q bar and Q. Q is the input, output, which actually tells what the state of my latch is. Q bar is just for ensuring the right operation. Right? The question is, how do we actually employ this enable signal? Fine. And you'll see that most of the sequential circuits, so most sequential circuits, they simply use an enable signal that repeats at a constant rate. And such a signal we refer to as a clock signal. Fine. So something like this. You have a clock, it is a low pulse for some time, then a high pulse. Then it repeats likewise with some frequency. Fine. So we actually have this kind of a signal, and this signal we apply to the enable input. So this is what is being applied here. Fine. Now this signal, it has a low pulse and a high pulse. So obviously it's pretty clear that in these durations your latch will be enabled. Enabled in the sense whatever is at the external SNR, it will be passed on to the basic SR latch. Fine. And this is a clock signal. It's a very important signal. And a circuit, let me add here, a circuit whose I'm generalizing is whose storage elements, in our case, our storage element is the latch, can only change when a clock signal is active. Such circuits are referred to as synchronous circuits. You have to be specific, synchronous, because these are always sequential. So synchronous sequential circuits. So the existence of a clock in your circuit means that this is a synchronous sequential circuit. A majority of the sequential circuits are designed as synchronous, which means they will always have a global clock signal. There are some circuits which are sequential, but there is no global signal, no clock signal. So we call them asynchronous sequential circuit. But most of the circuits, sequential circuits, they always have a clock. Fine. So this is the signal we apply at the enable input at the C input. Fine. So every time a clock pulse goes high, we make sure S and R inputs, they have stable values so that your basic latch can operate without going into the indeterminate state, without breaking down into oscillations. So this is one of the method. The second method we'll cover that in the second video. Let's stop here.